Hello, everybody. This is a rather unconventional startup, but I wanted to come in before the stream started and just let everybody know that tonight's stream is dedicated to the memory of one of our favorite SkyTour live stream members, and that's Cindy Murphy. We loved having her here. We enjoyed talking to her, and she will be very much missed by all of us. The universe has drawn her attention away from us for a while. Our sincerest condolences to her family and to all those whose lives she touched. I especially want to thank Heather Murphy, her daughter, for contacting us and letting us know what had happened to Cindy. So good night, Cindy, and we'll see you in the stars.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hey, everybody, it's Mark. How are you? Nice to see you. Thank you for joining us this evening for SkyTour livestream. And I want to say, if you hadn't seen it, we did a dedication to Cindy Murphy, who is one of our longtime viewers. And unfortunately, she passed, and her daughter Heather had told us about it. So I wanted to make sure that I put up a dedication to her. So this stream will be dedicated to Cindy and her quest to understand the universe. Of course, with me naturally is Daryl Mason. Daryl, how are you?
Hello, everybody.
I'm good, thank you. I'm glad that you could come with us tonight and hang out. I will be.
Been a while.
Yeah, it's been a while. Yeah, so this is it's actually a live stream. Um, I was in Arizona at the new site, and one of the things we're gonna do is I'm gonna show you the pictures of the new location. As I took a bunch of them, and I took a bunch of technical shots too that I think you'll appreciate, showing look angles and things like that that you'll understand a little better. The buildings out there exist already, and ours is building 0 on the site, and it needs some tender loving care. So we're going to be bringing people in to do a makeover to the building and get it looking good, within reason, because we're not made of money. We can't do that, but our money's going to be spent on the equipment rather than the building. The building is working as it is, but I want some things fixed on the building.
I have to ask.
No.
Building 0. I mean, was this person into computers or digital or something? Most people would say building 1.
I know. Yeah. Well, it turns out that building 0, all right, and building 0, 1 through 9, the person that's curating the site, the person that we're doing this through, is the director of the Visitor Center at Kitt Peak National Observatory. So he will drive down to this mountain on days, and he'll drive up to Kitt Peaks Mountain on other days. So this is a professional site. There's a bunch of buildings, which I'll show you shortly. And these buildings are interesting because they are all roll-off roof observatories, and they're right next to each other, and each of them is occupied by a professional astronomer. And now we get one of those buildings as well. So there's serious science being done on the mountain here, and we have free, unfettered access to the building anytime we want. I've already been up there already without anybody even being there. And all the other buildings, the roofs open up, and you see the telescopes pointing every which way and doing things. And then up on the hill, up on the slight hill near us, is a big dome. And up on that observatory, there's like 20 or 25 separate cameras. And the roof is it's a 30 by 30 room up there. And the whole roof rolls off this 30 by 30 building up there. And there's all these geosynchronous satellite telescopes looking at the geosync satellites, which is really interesting. They're tracking the geostationary satellites, which don't move, obviously, relative to the Earth, but they do wobble in their orbits, and they're tracking the wobble in their orbits. And there's stuff they can learn from that. So it's really interesting. This, what we're looking at right here, what you're seeing right now, this guy here, this is called Messier 76. It's actually a planetary nebula, known as a bipolar nebula. You'll see it has these 2 lobes on it. Okay, very obvious. And then these here. Okay, this is in the constellation Perseus. And if we go to our star map, you can actually see where it is. This is Perseus. And if we back out a little bit and move a little to the left, you'll notice a familiar site, and that's Cassiopeia, the W. Okay, Cassiopeia, of course, being this beautiful woman with this absolutely stunning visage of herself in this mirror. Hey, that's just...
She's the queen.
Yeah, she is. She's the queen, and a very, very immodest one, I should say. She's sort of a woman who wants to stare at herself. But
that's how the whole story of Perseus and Andromeda got started. Was she was vain and she was boastful, and she made so much of her own beauty that she ticked off one of the gods or somebody, I forget who, and to punish her, they said she had to chain Andromeda to a rock in the ocean, and that the sea monster Cetus was going to come and eat her. Of course, boyfriend Perseus rode to the rescue with all the magic stuff the gods had given him, a helmet and a sword, etc., and that little owl, and saved her, and That was the whole story.
Wow.
And they're all parked up there in the same part of the sky.
I know. Forever to be at each other's throats. Kind of. Wow. Neato.
Anyway,
Yeah.
sorry, I do go on.
No, that's actually makes this fun. That makes this very, very interesting. Yeah, so this is, again, Messier 76. It's a planetary nebula. Now, planetary nebulae result when stars run out of hydrogen and they start, contracting because the core is no longer able to hold out the pressure and push out with pressure enough to hold that star up because the gravity's trying to collapse it. And so then as this core collapses and gets smaller, it gets hotter, and that causes a lot more radiation to go spewing out, so the star will tend to swell into a red giant at that time. And when that happens, the star could do several things. It could get large enough outside that the temperature gets very cool and it becomes a very red giant. But the core could get very hot, and so the helium that's in the core, the hydrogen was fused into helium originally, that helium could start fusing and become carbon, helium making carbon. Next in the periodic table, the hydrogen, helium, then to carbon. And then when carbon is being made, then the star can kind of survive a little bit with its pressure. Its radiative pressure is enough to hold the star up for a bit, but then eventually the star is going to run out of all of its nuclear fuel. And if it's a star like the sun, it's not massive enough to cause a supernova and become a supernova where it all collapses. But it might just quietly collapse down. The core collapses down. And what will happen is, as it does, the outer layers get kind of puffed off in what are called thermal pulses, because that goes poof, poof, poof. Okay? And as it does that, we see things like this in the sky. This is a oxygen 3, O3. That's O with a Roman numeral, I, Roman numeral 3, O3. And that looks greenish blue to our eyes. And we see a little hydrogen out here. And this is what we typically see with planetary nebula. We see a lot of oxygen. We see a lot of hydrogen. And obviously, there's a lot of other elements in there too. And many of these elements we're looking at were made with the star when it was made, were built into the star, part of the outer envelope. Okay, and that's something that we don't necessarily know how much are the percentages. We can figure it out, like what percentages of oxygen was made by the star and what the star was made, or what part of the oxygen composition was made with the star when the star was made. In other words, it was already there. So that accounts for the different colors. So now in here is going to be a little white dwarf in here, and I'm not sure where this one is for Messier 76.
I was just about to ask. I almost
That
think
one?
I see something. No, a little higher.
Let's go look.
A little bit to the upper left. It was right on the edge of vision for me. I'm probably making things up in my brain.
Well, we were trying to go to the logical center. We think it should be here, but I don't see it. So either, it could be in this cloud. It's just not showing through. Let's try this. Let's pull this green out of there a lot and see if we can see a star in there somewhere. Yeah, no. I don't see one yet. I do see this modeling here, the different texture inside this nebula. Well, nothing. Well, anyway, that's pretty interesting. And we'll just come back to this now.
It's pretty tough.
It is beautiful, yeah. I'm going to back out for a minute. And let's show you the full field here.
Michael H. makes a good observation.
Yep.
That looks like a bar magnet.
It does. It does look like a bar
Probably
magnet.
something analogous going on there.
Now, it might be true. And what that would mean is that the North Pole and the South Pole would be one of these here. It's a bipolar nebula, so that could make a lot of sense. And there's a red star right here. Let's go find out some more about that red star. I wonder if this red star is actually a red giant or just a... It's going to be a red giant, most likely. And we are upside down, so where is our red star? It's right here.
Right there.
And it's a K5, so it's actually a regular hydrogen-fusing star, a K-type star. A K number 5, so K 0 through 9 on the scale of the temperature of the OBAFGKM scale. And it's a K5, meaning that it's, halfway into the Ks in terms of its temperature. Cooler than the sun. The sun is a G2. Okay, G numeral 2. This is a K numeral 5. So we go OBAFGK. So they're much more orange than our sun, and as you can see, it is. This is our field of view, for those that don't know. And notice it's sort of upside down. You have to turn your head. But that's why it's to the left of the nebula, and indeed, it is to the left of the nebula. Really cool.
Top left in the diagram corresponds with the right side in your image.
Yeah, so if we come here, the top left is the top right in our view here. And this right here, this area, that star right there, is that star right there. So it's at the top left. You gotta rotate your head around and then... But anyway, as you can see, I've done quite a lot of these. I was waiting for you guys while we're getting started. And I did 128 frames at 20 seconds apiece. And I'm now going to save it for the first time tonight. I haven't saved it at all yet. I restarted it a few times. And now we'll save it exactly as seen. And there it is. That's Messier 76.
Mort asks, what power is this scope? Mort, the field is about 1.5 degrees long by 1 degree tall. Power, I forget, what's the effective focal length of the system, Mark?
503 millimeter is the effective focal length.
I would guess your magnification, if you could say it at the moment, what would you guess? Pretty low.
Yeah,
20x or less, I would guess.
Yeah, keep in mind we're using a fairly high resolution camera image, but here is the actual size of that object in the field. See, so clearly we're able to zoom in quite a lot, in order to show detail.
The telescope has a 10-inch clear aperture, which is what they usually figure telescopes by. Power is really secondary. This is a low power wide field system.
It is.
Operating at f2 or f1.8.
Yep.
So you're getting deep, wide field view, relatively wide field telescope.
Yep. I do want to say hello to PG. Hi there, Petita. How are you? Fantasy and Michael Hendricks with us. And then we have, going down the list here, Wayne Pinkham is with us. Hi, Wayne. How are you? Tim F. Woohoo. Roy Batty's with us. Nice to see you, Roy. And let's see who else is with us that I didn't say hi to. Rockstar's with us. Karen Belmont is with us. Dagger Spell's with us. Hey, Dagger. Sam S. is with us. Good to have you all here. Tricia Ferreira, I see here. Carl Becker, I see here. Nice to see you guys. And Raul Babadia is with us. Hi, Raul. How are you? And I might have missed some. I'm looking for someone I might have missed. Let's see. Ray Bopel's with us. Hey, Ray. How are you? Yeah, it's good to see you. Michael Galia's here. Yeah. And let's see. Toner Lowe's with us. Nice to see you. Toner Lowe. That's like, every time I read your name, I think I better check my printer. That's cool. And Stuffy, what's going on? Yeah, Don Kunzer's with us. Hi, Donald.
Stuffy?
Yeah, Stuffy's here.
I must have missed him. Hello, Stuffy.
Yeah, easy. Stuffy's here. Waldo Hiding, what's up? Let's see now. We're going to take a trip to a different object in a little while, but first I'm going to give you that update on the observatory. And let's start with looking right over here. Okay, so this is our building right here. Okay, and these are all the other observatories on the mountain. And we're in the mountains of Benson, actually south of Benson, Arizona, in the mountains. I say mountains. The altitude is 3,500 feet. We're at 3,500 here. 3,470 something. And so the sky is gorgeous. This is the eastern horizon here. East is this way. And what's interesting is you think that's sticking up like in the way. It's not. It isn't. Because that is less than, from the point of view of our observation with the telescope, it's less than 5 degrees above the horizon. And we never look below 5 degrees above the horizon. So here is the observatory dome up on the building, up on the mountain, just a little farther. And it's literally up the road. So right behind us here is all the buildings. And this is up on the top of the hill. On the other side of that is a long 30 by 30 building where they're doing the geostationary satellite stuff. And so back down, you see our building here, the roll-off roof segments here, all the way down the line for all the others. And we've asked someone to come in and look at the building and check it out. This is the opposite end of that walkway, opposite end here of the observatory row. And this is another observatory. This roof rolls off to the south. I don't understand why, but it does. And that's literally the only reason why, one of the only reasons why we didn't decide to take this building, because this one was available too. But it was just not the best. Okay, this is the inside of our building. It's, like I said, it's something that was pre-built and needs some tender loving care. And we're going to try and do that. This is the back side with the roof off. What?
Which way does the roof open on this one?
Toward the east.
Okay.
Yeah. I like the roof rolling off to the east because, you know, stuff in the east is going to be overhead before long.
Yeah.
So I like that. These are the pier mounts for a previous pier, and these are being taken out because where these two rocks are, this rock is a little more over here. These are where our telescopes are going. We're going to have a pier here, a big tall 60-inch pier, and another 60-inch tall pier right here. You know, that's going to go up. And both telescopes will be able to see very, very low to the horizon with this setup.
Fantasy asks, how did you discover this place?
I discovered this place through talking to people. One particular guy I talked to, Tim Hunter. I went down to see David Levy, the comet hunter. He was at this observatory hanging with this guy, Tim Hunter, who's a professor at a local college. And Tim Hunter, David couldn't make it out the day I went down because it was out. You know, these are out in the middle of nowhere. And so we sat and talked for a little while, and then Tim mentioned this as a possibility, along with several other places actually. And we did visit a place in New Mexico as well, western New Mexico. The problem with that place, it's a great place. Skies are exceedingly dark, as they are here. But the problem with that place was that out there, the problem was that the people there decide if they're going to open, because it's a giant Quonset hut building, and the whole building rolls off all the telescope piers. So if you roll off, everyone's exposed. So they're extremely conservative. If there's snow in the forecast anywhere in the next several days, they will not open. And then for the entire month of July, which is monsoon season, they don't open at all. And I felt that was probably not going to work. But they're great, and they may still have a way for us in the future. That there might be something that we can do with them. So these are just some of the images. Okay, now here's the images that are really cool. These images show the actual look angles. You see a white plus sign here, not the yellow one, but the white one. So this shows that looking to the north on the furthest pier, the rock closest to us in that picture I showed you, we're looking at an elevation angle of 9.5 degrees. So we can look down to about 10 degrees. And of course the North Star is way, way up, almost out of this picture, actually. Okay, and then this guy, this one, is outside just looking. And you get an idea. It's like, here's the white plus sign here, and this is, we're just getting a little a better. I just did it because I wanted to do it, but you also get the altitude because you see it's 3,605 feet actually from this point. And then this guy, this is looking toward the east from Pier 2. Pier 1 is over in this corner. Okay. And we can see 21 to 20.9 degrees up to this. And this is the actual altitude. And this is from the telescope height. I was holding the camera up at the height that the telescope would approximately be. So these are all approximate numbers, but they're pretty close. Tricia Ferreira asks if the heat hurts the equipment. No, we've been dealing with 120 degree temperatures in the building we're in now, and there's no problem. Okay, this, now if you look down here, you can see where we're looking. We're looking out to the west, and here we are looking to the west, and we can look at 14.2 degrees above the horizon from here. Okay, so that's not bad. And then this is for the, again, I don't know how to label these piers. Pier 1 is the one that's on the north side. This is on the south side. And there is this large opener. Now, right now, you look at the altitude or the height we're looking at, it's 25.8 degrees. Now, what that tells you is in our current setup, we can't look at objects to the side closest to the door opener, all right, unless they're at 45 or 48 degrees. And now we have it at 25.8. Okay, the horizon's literally only here. That's what this red line is. So this is really cool. And this is looking down. This is the south is this way. This is Pier 2. This is Pier 1. These rocks. Let me actually bring these down. So here is Pier 1 on the north side. Here's Pier 2 on the south side. Okay. And then from Pier 1, we have a 39.3 degree angle, up angle. And it's kind of interesting because look out, that looks like it's really high, but we can see 39 degrees up. We normally would have to go to 45 or 48 in our current setup. So this image is very misleading, but it's accurate. Okay, and here, the horizon's here. There you can see now we are 13.5 degrees up from Pier 1, looking toward the south. So we can look at anything above 13 or 14 degrees on the southern horizon. Right now, in our current telescope system, our limitation is 25 degrees. So we've got a lot more detail that we can see here. Okay.
So you still won't be able to see Omega Centauri.
Maybe not true, and I'll tell you why. Because on the 60-inch pier, all right, this is just a look angle when we hold our camera up in the air. But if you look, let me do this. If you do this, if you think about it, if you have a equatorial mount where the telescope flips upward, all right, we're going to be able to see right to the horizon because it's a 60-inch pier, and when it goes upright, the telescope itself is sticking out of the top of the building because that pier height takes the telescope right to just under this rim when it's in the flat parked position. then it's going to flip upright, and then it can twist and turn to actually look toward the horizon. I think when it's operational, we'll be able to see distant cactus in the desert, to be honest. So we're going to have a much better view. This is a 7 degree. This is toward the west. A 7.6 degree look angle. And that's only going to be, but this is the low end. It's going to be higher than this. See? And then this is now toward the north. From Pier 1, we're going to have a 19 degree look angle from there. So it's not bad. All in all, this is a beautiful sight. Temperatures are a little chilly up there, but it's okay. So I hope you guys enjoyed that little tour. And that is where we're going. We're hoping to do this by January or February at the latest. Okay. All right. So let's save this one more time. This is more than enough for this guy. We've given ourselves enough to process this object. Look at all the detail in there, Daryl. We've never seen that kind of detail for this. It's always been kind of smooth, and now we're getting some really nice detail.
Mort asked a little earlier, do you need that many exposures to stack?
Yeah, that's a good. I'm glad you mentioned that, because I was thinking about and then decided not to say what I'm now going to say, because it shows me that I should have said it. Okay, and that goes here. If you look right here, you can see that we've got 100 and going on 170 exposures here. There'll be 170 by the time I finish this little thing, maybe more. And if you want to think about it, if you take 20 exposures and you stack them and make an image sandwich, what that's doing is it's removing all the noise that you can see when you zoom in on an image. When you zoom in on an image, okay, and you go way, way in, no matter how many you stack, you can still see noise. See? Here's the noise. See all that stuff here? That's noise. And we want to get rid of as much of that as we can. So a rule of thumb is that if you stack 20 images, if you want to get half as much noise that you have with 20 images, you got to stack 40 images. So you got to double the amount of images you want to stack in order to get it to actually be less noisy. And that's what happens. Basically, the rule of thumb is double the exposures to have the noise.
And now he asks, do you save the individual raw frames?
The idea to save the individuals is exactly what I want to do, and wanted to do from the start. The only problem is disk space, because they're going to be saved as TIFF files. TIFF files are huge, and we would have had 172 TIFF files at many meg each. And so what I want to do is I want to take those files and be able to save them. But what we have to do is get some more people to sign up for our Patreon to support us, so that I can actually buy the extra server space in order to take the individual frames as well. Because I'll make those available to everybody as well, if they want to do their own stacking. That's not a problem. I want to do that. But if you're interested, go to skytourlive.org and click on it, and then you can go to our Patreon. You can click donate, and you can donate to us or something if you want. We are a 501c3 nonprofit doing remote astronomical teaching around the world. We'd love to have you on board with us. But we'll eventually do that as well, yes. Okay. So let's see now. Jessica S. Hi, Jessica. And let's see. I had another question I thought I saw here. Oh, yeah, SkyTour. SkyTour Live fan. I just love your name. I wonder why. You ask, what are your thoughts about the Seastar S50? It's a nice telescope. It's a nice scope. Now, if you pointed it at something like this, you're not going to get this quality with that scope. Okay, that's a small aperture, and you're going to get something less than what we do by far. But you know what? That's not knocking it. It gets you into astronomy, it gets you into astrophotography. It's awesome. And to that end, they're worth it. And they're not that expensive for what you get.
It has a lot of bang in the buck for the price. Ultimately, your limiting factor is the 50 millimeter aperture,
Yeah.
which is a hair under 2 inches. C-Star recently, or ZWO, I guess, came out with an even smaller one, a C-Star 30. And I have to wonder, I mean, I know they do some amazing things with digital cameras and processing and all that nowadays.
Mm-hmm.
And the C-Stars will do all that for you. But a 30 millimeter aperture, I mean, that's about 1.25 inches.
Yeah.
And I just don't know how that thing is going to do very much.
I don't know. I really don't. I think that it's cool. I like the fact that they're getting people into astronomy. I really do. But I also don't want them to turn people off, because people say, well, what's that stupid thing? What's that little thing? You know, what's that fuzzy thing? That's it? You know, so, but I understand, you know, there's limitations, and for the money, you get what you pay for.
Well, and the 30 is about $350, I believe, and
Yeah.
that's a lot of bang for the buck.
Yeah.
Ultimately, I mean, you're limited to a 30 millimeter aperture, though.
Yeah.
About 1.25 inches. Be interesting to see. I've seen the S50s. I haven't seen any of the 30 millimeter results yet.
Okay. All right, we're going to save this. And for those that don't know, and many of you do, every time we save, you see how this green bar comes up and it says it's been saved, blah, blah, blah. Okay. What's happening is it's being saved to our server. So you can go to skytourlive.org, and you can actually go scroll down, and we'll show you how to get to this picture, which, by the way, as we're talking, is being uploaded to that server just as we're speaking, thousands of miles away. So it's really cool, and you'll be able to get this picture immediately. So, you know, as an example. And what is that picture? That picture is going to be, let me save the ping file again. Okay.
I'm looking for the direct link to your server.
Okay, here's the picture that's going to come up.
Post it.
Let's see, is this it? Yeah, here's the picture that's up there, and you'll be able to download it immediately and look at it, enjoy it, have fun with it. So there's a lot you can do. We make every picture we take available to you, all the raw ones. If you join our Patreon at some of the higher levels, what you can do is you can get these fully processed, and they're ready to put on products. And if you want them already on the products and you don't want to do it, up there in the upper right here, you can go to our SkyTour shop and buy yourself some really cool Christmas presents. Okay, and you know, ask Daryl, he just got one. And,
the mug.
that's right. We sent Daryl a Pleiades mug for all he's done for us. He's been very helpful.
The thing is huge. I make 2 cups of coffee in the morning, and now I just fill the mug once instead of twice.
That's cool. And then the Pleiades picture looks beautiful on it. It's really pretty. It's a nice, really sharp-looking mug. And that's just the Pleiades. We got a bunch of other mugs too. You can get blankets. You can get shoes. You can get boxer shorts, for crying out loud. You can get journals, books to write. You know, notebook journals with beautiful imagery on the covers. So it's really, you got a lot of things you can get. So just check out SkyTour shop on Etsy. Okay, and you can find that right here, skytourlive.org. Check it out. You know, and again, we need your support. You know, we got a lot we're trying to do, and to be fair, I'm not making a dime on any of this. I'm not charging anything. Everything I'm doing is unpaid, so I'm not looking to get paid. I'm just looking to better the experience for everybody. That's all. All right, I think 190 shots is more than enough. I'm going to take this and save it. We don't usually do 190. This is just because I started this about 20 minutes before we even got started.
I still think I almost see the white dwarf.
Right here?
But, yeah.
Yeah.
If you zoom in, it'll go away. I swear I see it when you're farther out like that.
Yeah, actually, if we zoom out a little bit, you see like a hot spot right there. But I don't know if that's the white dwarf. I'm going to have to find out. Now, the other thing could be, this could be it. And it's skewed because there's some dark nebula in here that might be blocking the rest of the extent of this nebula. But it looks pretty much like it goes like this and then goes like that. And imagine that in 3D, so it kind of looks like this. You know?
Maybe.
Maybe. All right. Very cool. All right, we're going to get out and we're going to go back to fit the width for our entire shot and go to our low light shot for 1 second. And there we are. And there it is in low light. Okay. Okay, so now we go back here to our wonderful planetarium. And we're going to bring up some of the other objects. I actually set some of these up ahead of time for you guys. We're going to go to Sharpless 188. This guy's cool. This is a planetary nebula like this other one. But it's really fascinating because it's very, very different from this other one. So we'll check it out. It's right nearby.
Or it asks another question.
Yep.
How many people operate the scope? Have not seen live show in a long time.
Oh, I know. I'm the only one that does it right now. I'm actually in the process of writing a manual so others can do it. But once we have this telescope that you see right here is on what's called a fork mount. You can see it has mounting points on two sides of the tube, and then there's a fork underneath. Okay, and depending on where you move it, you could actually put the telescope in danger. So with a different type of mount that we're looking at, that's minimized. We won't have as much of a problem. And that's what we're trying to do, is get that particular mount in place. We're going to change this over to that new mount. We have a second telescope that we're putting in the building first, and that's going to be a Celestron 11, and it's going to have what are called narrowband filters, a spectral imaging system, and it's going to have a filter like we're using here. Okay, and that's kind of cool because that'll give us the opportunity to do some really neat things. That said, we're going to, let me just take a picture of this. We're going to be doing that. I already did some testing, and I started setting up the optical train. That is all the stuff that's going to go into it. And that's looking really good right now. Let me see if I'm going to annotate this and bring up our annotator and see if we can hang on a second. All right, and we're going to just see if we can find what we're looking for. Okay, that's Hipparchus star 7251. We're going to center that in the view. See, we got some cool tools. You know, no matter where you are in the sky, we can identify where we are. That's kind of cool. All right. Okay, so Hipparchus 7251. And let's go zoom in here. What's this guy? That's not, then maybe this guy? Yeah, that's 7251. Okay. So, I'm going to center on that and tell the telescope to go there. Not go there, but to just set its coordinates for that. And it's an alignment thing. Okay, now, when we come out of here and go over to this object here, okay, actually this guy right here. And now tell it to go there. Now it'll be dead center in our shot. Okay. All right, so right now it's probably dead center. And you can kind of see a little bit of red here. Let's go and do a 25-second shot of this. We can either say 25S for 25 seconds or 25,000 for 25,000 milliseconds. Okay. Okay. All right. There we are. All right. So now we're going to do 25,000 millisecond shot right here. The object should be right in the middle. So we're going to live stack this. The previous stack was Messier 76, the little dumbbell nebula. That's up on our server. We can clear it. And down here in the lower right, you've got a progress bar showing you how soon. We have 3 seconds left. And then we should see our first image here. We're also using a filter called the full width half maximum filter. That's going to help. There it is right there. And that means I got to move over a little more, which I'm glad I saw that. So I'll move it over. I'm going to move us over a little more. It's easy enough to do.
Michael H., whether a satellite or a planet or a moon is tidally locked, would have nothing to do with its gravity. Would your weight change during orbital period? Not that you would notice, at least. I mean, if you were on Io on the side facing Jupiter, would you feel like Jupiter's pulling on you more than if you're on the far side? Technically, I suppose that's like a tidal effect, but I don't think it would be noticeable to somebody theoretically standing on the surface of Io.
I think you're right.
Mort Ort says there's a supernova in Camelopardalis.
Okay. Okay, I've got a my telescope is slewing at too high a rate, so I have to do this find again. There's 7251. Okay. So, knowing that, I just have to move myself over now to the east. Which supernova is it there, Mort? Oh, shit. Hold on.
Supernova SN2024 ABFL, it looks like.
Okay.
It's in NGC 2146.
Oh, okay. Is that a galaxy? Is a supernova in the galaxy?
I assume so.
Okay.
I'd have to look up NGC 2146.
Okay. Hang on, let me... Yeah, I thought that was wrong. My guide speed was set wrong. Now it's going to move. Okay.
Yes, it's NGC 2146, the barred spiral galaxy, constellation Camelopardalis.
Okay, we should check it out then.
Alright, I'll keep a page open
All
in
right.
case we need a reminder.
So who wins the internet for the night for saying that for us?
Mort Ort.
Ort. Thank you, man. Camelo Pardalis should be visible. All right. This is going to be visible too. All right, let's get rid of this. We don't need this. 7251 is right there. All right, we'll come back here real quick. And let's go over here. There it is right there. Here's 7251. And we move it just... Oh, that's upside down. I might have moved the wrong way. Well, I'll do a quick shot. There we are. Yes, to the right of 7251. So I was right to begin with. There's 7251. It's over here somewhere. Yeah, so it won't be in here. So I will move the telescope here. Yeah, right. Okay. All right. Let's do it quickly. Let's go back to our 1 second low light mode. There we are. All right, and then we'll say, let's do an adjustment here, and now we'll just head to the west a little bit. Okay. Come back a little bit, because it's going to be right here. Okay. So it should be right about here now. And so 25 seconds off and running, and now we'll finally get our imagery of this new planetary nebula. It looks very different from what we just saw. So that's what we're looking for, and it's going to be
Right back where you started.
no, not exactly, because 7251 is off the screen to the left here.
Well, the crescent on being on the left like that, I think that's what you captured the first time.
Yeah.
Where you started jockeying the telescope.
Yeah, there it is. So this is a fascinating guy too, and I'm gonna let me just see if I can pull out a little more detail. Let me do a color correction first. There we go. So you can now see a little more of the details of this ring. It's actually a tenuous sphere. And pull this out. Pull our black level back to the left of the peak. Kind of pull out as much detail as we can. There we go.
That's planetary.
It is. Here, look.
It's like an H2 region.
Watch. See, planetary nebula. And the white dwarf might be this star right here, right of the sea. Is that the one? It's in Cassiopeia. It doesn't tell you what that is, so it may not be this. I might be buried in here somewhere. What's this guy? I have a lot of star catalogs I've added into this to show these details too. Hang on. All right. So this beautiful object, tenuous as it is a beautiful planetary nebula, and you can see the extent. Let's try and drag out some detail. This will kick it up a notch. Let's darken up the space around it. That's not really important data. There we go. Interesting.
Looks like an ear.
It does, doesn't it? Alright, let's... Interesting thing is that our system doesn't know what this object is. It doesn't have this catalog, which I think is interesting. It doesn't have the Sharpless, and this is SH2-188. It's a PN, planetary nebula. Alright. Really nice. Alright, and now a little more. Okay, let's see what this is going to do for us now. I was in Arizona for literally 13 days. So, I had to teach astronomy in the desert, and then I went to Benson to take care of all these arrangements here. I did not go to New Mexico. Marianne went to Mexico. Hello, Goblin, and hello, Keith Evans. How are you guys? Mort Orr says the supernova is like at magnitude 16 right now. So that's pretty faint. And however, I did see magnitude 17 geostationary satellites with this telescope. Michael, I missed a question you must have had. Slightly random question. Oh, tidally locked. Daryl answered it for you. Sorry, Mike, I didn't see it. Most epic 47-year windstorm, Keith Evans said. Big storm in Washington. I assume Washington State?
Yeah, that.
Well, that's the, what do they call it? Up here we call it a nor'easter. But over there it's, what do they have a special name for it.
Oh, they call it a bomb vortex.
Yeah, that's a bomb vortex or something.
I hate that word. Yeah, somebody thought it up 2 years ago, and now everything's a bomb vortex. We get noobs here in Colorado. We occasionally, the worst storms we get here, some of the worst on the Front Range in Colorado, are so-called Albuquerque lows. That's when a big low-pressure center forms to the south of us, and the storms rotate counterclockwise and hit the Rockies coming from the east and the south and the north, and it's called an Albuquerque low because that's where the low pressure is parked. But nowadays, people like, oh, it's a bomb vortex. It's a bomb vortex.
It's a bomb. Leave it at that.
Bomb cyclone is.
Bomb cyclone, yeah.
People are correcting me.
Yes. That's what it is. Bomb cyclone. That's the word of the day.
Marianne is here. Hello, Marianne.
There she is. Hello, Marianne. I was talking to her earlier. I'll be at Contact in the Desert again this year, as it turns out. And hopefully, so will Marianne with her talk. I sent a message to them to let them know they should really have her and Dave do their talk. If they can. I don't know that they can. Let's see, where's my sent mail? Just gotta find out. Oh. That might be a problem. Ah, yes. Once.
You mentioned that observatory in New Mexico where
Yeah.
it's either everybody gets the roof rolled off or nobody does.
That's right.
I guess that's what happens. Well, of course it is. What happens at that Bray Falls place?
Yeah,
down in Texas
same
that's
thing.
building now?
Yeah.
I mean, God, he's got like 100 telescopes in one building, and
Yeah, he's got a...
he's building 8 buildings now.
Yeah.
That's a lot of telescopes.
Well, we may have one up there someday. Who knows?
I wonder if he's overextended himself. He actually only has, buildings 3, 4, and 5 are actively occupying telescopes right now.
Yeah.
I'm not sure what 1 and 2 are doing, yet he's building another 3, and at the same time he's lowering prices on at least some telescope sizes.
Yeah, I mean, our telescope sizes would be $2.99 a pair.
His biggest one was $9.99 a month.
Yeah, but that was for like a 17-inch.
Well, yeah, he lowered the price.
Mm-hmm.
So I wonder if he's feeling a pinch.
Well, he might not be getting takers for it. That's why. And so he's looking at what other people are charging too, most likely.
Law of supply and demand.
I mean, we got our building here is really quite a deal because the building in Benson, we're going to be able to put as many scopes in there as we want. And we're going to be able to fit 2 instruments in there comfortably.
Yeah.
We're going to have an all-sky camera outside. We're going to have a weather station outside. The weather station donated by a SkyTour listener, viewer. We'll go to 25 on this. It's a 22. And then we'll move to the next guy.
I still see an ear.
Hey, Rich McFarland, how are you? Nice to see you. Thank you for joining us tonight. Yeah, Mort from the Oort Cloud. It's classified as a planetary nebula because that's what it is. It's the shell of expelled gas from now what is likely a white dwarf in this region. And I'm not sure where the white dwarf is. You're looking for a blue... That might be... This star here looks a little blue right here. I wonder if that's the guy. Wonder if that's the guy. It could be. Could be. It's roughly centered, and it is bluer than the others around it. White dwarfs are very hot. It's ionizing this gas. This big gas ring here. This is a gas sphere. Now, why we see more here than on this side? That has to do with a lot of dynamics going on in this region. Hey, Tiffany. Tiffany's with us. Dean Bustador, how are you? All right. All right, so this object now, how would you not make the mistake of classifying this as an ionized hydrogen region? Because that's exactly what we're looking at. It's an ionized hydrogen region. But how do you differentiate it from being also a planetary nebula? Well, when we look at the spectra of this object, you're going to see that you're going to have other elements in here. You're also going to find the white dwarf that's the cause of the illumination, the cause of this exciting of the hydrogen atoms. And that's going to tell you that it's a planetary. And there's a few other keys to discovering what these things are as well. All right, let's get rid of this guy I don't need. Okay, so I said we'll go to 25, went to 28. All right, so we'll save this now and move on to the next thing. Save exactly as seen. All right, so there's that little planetary nebula. This is a new object. We haven't really done much with this, I don't believe. And let's go here now. And go into our low light mode. Go back to our full frame. There we go. All right. Now back in our planetarium, we're going to check out the next thing that I felt we could look at. And that is LDN 1271. It's a beautiful dark nebula right here. I say right here. Where's right here? Well, it's right there. There's Cassiopeia. And it's right here. Now, this is not the equatorial coordinates. This is the zenith coordinates. There's the equatorial coordinates. North is down here. So we're well above the north. We're almost overhead. Kind of, sort of. So that's what we're going to go check out. We're going to check this thing out. There's a lot of activity here. So we're going to check this one out. There we go. You'll watch the telescope move now. There it goes. And you'll see our STLS icon move into this box. Just a minute. Here it comes. Okay, there's a delay between what you see here, what you see here, and what you see there. That's how it works. All right, let's see if we have an idea what's in here already. If our system knows where it's located. Oh, there it is. So this is part of NGC 7822. So we can go down here. Let's bring it up. There we are. 7822 is a beautiful nebula rich with these really cool objects in it. And you don't see much of anything right now, but that's only because we have to do an exposure here to show you. Here we are. Okay. So that's good. Now, I just love intelligent systems, and we've got a nice intelligent system here. Okay. And we'll do a 25-second shot here. Okay, we're on our way. You can see the a yellow bar over there indicating progress. So we'll come out and go into our live stack. The live stack is obviously designed to take images where we minimize the noise over it by taking many pictures and stacking them on top of each other. Make an image sandwich. The first of which we should see right now. And there it is. Wow. That's pretty. That's really pretty. And that object we're looking at, I'll show you in a minute here where it is. let's first do this. It's really nice to be back up and running because when I was out in Arizona, I was really wanted to do this. Marianne knows because I told her many times, I want to stream tonight. I want to stream tonight. However, with the jet lag and everything else, I couldn't get to it. I was just like, bleh, couldn't do it. Marianne, just so you know, at the very beginning, I read a dedication to Cindy Murphy, and her daughter Heather Murphy had contacted me and told me what had happened. For those that have joined us who didn't see, I will show you the dedication. This is what I had in place as we first started up the evening. Again, Cindy has left us, and she was a big fan of SkyTour, and her daughter Heather had contacted me to tell me what happened. So I wanted to do a nice dedicated show for Cindy tonight, and that's what this is. Okay, and as I said, she is. Universe has drawn her attention away from us for a while. So good night to Cindy. We'll see you in the stars. And that is, unfortunately, the bad truth about this. She has passed away, and we just loved her. She was a fantastic person in our streams.
She was always nice to me.
Always, yeah.
Nice lady.
Always nice to everybody, actually.
Sure.
Yeah. I know we talked to her on the phone several times, actually. Marianne did. Okay. All right, so. Hey, old school, how you doing? I saw you arrived earlier, and I forgot to say hi to you. My mistake, sorry. Yeah, GC 7822, really pretty. Now that we have some data here, let's actually save this with the annotation so we actually have an image with what we've got here. So now, what's actually saved on the server that you can go get is this image right here that I'm bringing up. Right here, with all the details on it for what we're looking at. Really cool. Excuse me. I got a cold on the plane on the way back, and so I'm just fighting it off. So far, so good. Let's zoom in now that we have 8 shots here.
This looks familiar.
It is. There's a pillar that we talked about.
Yeah.
Another one right there with some details in it. Very nice.
Yeah, okay, I recognize it now.
And this is NGC 7822. That pillar is the result of this young hot cluster ionizing all this gas, okay, this hydrogen, and causing the electrons to fly off the atom for a period of time. And when they come back in, they give off light, characteristically red for hydrogen. There's a number of other transitions that they do as well, but hydrogen alpha, this one here, that you see the red, is the dominant one. Now, I want to also mention that in honor of Cindy Murphy, we are doing a giveaway tonight. You already can see that in the chat. And if you guys will pick a number between 1 and 1,000 and put it into the chat, Tiffany Echo, again, one of our unbelievable super fans, is going to provide us with a pair of binoculars courtesy of Michael Tarr and Tiffany Echo. They're a pair. They're a power couple pair when it comes to these things. And they will provide a pair of Celestron binoculars to the person who gets closest, above or below, to the number that has been pre-selected. And so I wanted to thank Tiffany for doing this. It's very nice of you. Yeah, I'm just reading some messages here from Tiffany. And okay. Yeah. Okay. So put your guess in, number between 0 and 1,000. And the best number, the closest number to that number, will win a pair of binoculars.
Tiffany says 2 winners tonight.
2? Wow.
She says.
Let's see this.
You can only use one set of binoculars at a time.
All right, so she says 2 people closest. Okay, look at that, guys. Tiffany, thank you. You are so sweet. You know, very sweet. So, if you aren't the primary winner, you can be the secondary winner. So all you have to do is be closest to the number picked tonight, and 2 of you will win. Fantastic. See, that's the, Daryl, I mean, you talk about the people that are quality. Tiffany and Mike, they've really demonstrated they're quality people. Outrageously cool people. I'm proud to call them friends. Oh, by the way, just to Tiffany and Mike, you may have heard me say before, I am going back to Contact this year. Just to let you know. So look at that. This is really looking pretty here. We're getting some nice details in here.
Very intense red part up in the upper right.
This guy right here.
Yeah.
Let me pull that out and color correct on that.
Marianne's going hunting. She's already been for deer. She's going again for elk.
Oh. I didn't know if she was actually going to go. Marianne, are you going yourself, or is that with Glenn? This is really pretty. Look at that. Okay, so I see numbers have been entered by a number of people. Sam S says 472. Donald Hunter says 256. Old School says 673. Paul Atreides says Dune. No, wait. He says 150. Richard McFarland says 5. And Karen Belmont says, you said something. I think you said, what did you say, 7? I think you said the first number you mentioned is the one we're taking, by the way. Okay, Michael Hedrick says 800. Rockstar says 777. Oh, Old School first. Okay, he said 673. Okay. Yeah, you don't have to say it more than once because, Tiffany is going through with a fine-tooth comb. She's not going to miss your number. But there's 2 winners tonight. Okay. Oh, we have 22 images taken here. This is gorgeous. This is really looking beautiful. Look at all the detail in here. Wow. That's really pretty. I just want to say something, by the way, just real quick about Tiffany and Mike. You know, they don't have to do this. This is so nice of them to do this. You know, we're not getting anything out of this. And we don't expect nor want anything out of this. And they came out of nowhere with SkyTour Livestream. I met them in person at Contact. And I found out that they are just the coolest people. They're friendly. They're very nice. And, you know, they are also very interested in getting astronomical instruments in people's hands. And that's rare. It really is rare. So, you know, we gave away telescopes originally from them. But the best entry-level system, and we'll still do that, but the best way to get into astronomy is a good pair of binoculars you can just lay down and look up with, because you immediately increase your capability to see the universe 1,000-fold with these binoculars. It's really, really something. So I want to thank Michael and Tiffany publicly for doing this. I know I must have done it before, but hey, I'm forgetful sometimes, you know. Just an astronomer, what do I know? Look, I'm hydrogen alpha face. I'm red.
I see a chicken.
I do too. There's the eye right there.
Yeah, that's his head and
Yeah, and there his. Well, it's a rooster.
tail over on the left.
Look, it's a rooster. See the thing? There's something on top of it right here. Well, it's on top. Well, it might be a chicken that was hit with a bazooka. It's in the process of disintegrating. That's funny. This is really nice. All right, we'll go to 30 on this, and then we'll go to the next item. And while we're waiting, I'm going to go check out what that next item might be. That next item might be the... Well, we got several. Yeah, okay, cool. Excelente. Very nice, very nice. Very nice indeed. Very nice. Okay. So this is an example of a region of space where most of what we're seeing here in this whole region, and I'll zoom out so you can see a little bit more. Everywhere we're looking in here, there's dark nebula. This is all dark nebula. It's not a void in the stars, a void at all. It's dark nebula, and you can see here the dark nebula sitting on top of the nebula. So it's here, and the nebula is back here, glowing in the background. And this is blocking you from seeing that. Zooming in here, you can see that very clearly. As we look here, you can see there's a dark nebula right here. And on the other side of it is a hydrogen emission nebula. And this dark nebula section here is blocking what's behind it. Same here. This dark nebula is sitting in the middle of the nebula. And it's blocking what's behind it. And you can see it tapers off here. So here you see pretty much purely nebula. And then you start to see strands of black in the way here. This is the dust. Dust made from countless supernovae beforehand. Okay, so again, the hot young cluster is here. And the hot young cluster is doing what young clusters do. They clear a path around themselves. It's called a cavity. They're making a cavity as their hot ultraviolet radiation and solar winds from the young hot stars are pushing outward. What those solar winds do is excuse me, erode material in their wake. So here, when we look here, the stars up here are eroding this area here. Let me explain that. Hang on, I'm trying not to cough in your guys' face. So these stars, with all their solar winds pushing out this way, are hitting the end of this area here, which is a very dense area. It's resistant to erosion. The area around it is not. This is less dense. So it's being pushed down and away. And this leaves a stalk. This is the dense part. And this stuff on the lee side is protected by this dense material, so it's not being eroded away. So it's pushing past it.
Same process as the pillars in the pillars of creation.
Yes.
What they call those nowadays.
Pillars are yeah, they're pillars or stalks, that's all the same. Pillars or stalks are fine.
Karen L. Belmont, dark matter is hypothetical. We don't see dark matter at all. It's postulated from perceived gravitational. There's more mass affecting the motion of galaxies than what we can see. By its nature, it's not visible, and they don't know what it is or if it's even real.
And the word dark just means they don't understand it. It doesn't mean it's black. This is dark nebula. It has nothing to do with dark matter. This is normal matter. Okay? But dark matter appears to be something that's non-baryonic, non-baryon matter. Baryon matter is normal matter. Non-baryonic matter is something that appears to be what dark nebula or dark matter is. So, Claudio Ramos is here. I think you're from Chile. How are you doing? He writes, are those formations thanks trying to read it, thanks to gas too? You're talking about these formations here, Claudio? I mentioned this is particles of gas and molecules of gas and dust in here, atoms of gas, of hydrogen, and then they're glowing red because they're ionized hydrogen molecules. This is light years across. So you could be inside here in a solar system completely protected and not even realize. You might just have a bright cluster in the sky, and that might be this cluster up here. And you might not even realize you're inside a giant nebula. So these are the pillars that are eroded by these stars. There used to be a lot more matter here, but these stars are pushing that material down. But this area here at the end is dense, resistant to erosion, and so it protects all the stuff behind it. So that's how that works. Okay, 42, that's good for now. So we'll save this. I think I should have renamed it first. I didn't rename it properly. So what I'll do is I'm going to rename it and then save it again. All right, so this is what we want, and I'm going to set the target name, and then that's what I was afraid I was going to do. It's like, yes.
See, Ramos, I assume you're asking, have stars already formed inside? If not, correct me, please. Are you looking at something from the past that is already happening? It's probably still happening right now. Yes, it's in the past because it's, I don't know how many light years away, but it's a long ways away. I assume thousands of light years, so what we're seeing happened thousands of years ago. Stellar processes like that, I mean, star formation in clouds, it could take millions of years. So, it's not happening all at once. It's a process.
Yeah.
Process.
That's correct. I'm going to look here.
When we see different heavenly objects, different areas of star formation, stellar nurseries, we're seeing the same things happening all over the sky, not necessarily at the same stage of progress. Some are earlier, some are later. Both are, this and Orion, they're both happening to us now. They're really happening in the past, but the processes are still ongoing.
Agreed.
All over the sky.
Yeah, it's a big time machine, you know. The youngest thing you can see is the person standing next to you, pretty much. The oldest thing you can see is the farthest galaxy we could see with any instrument we have. The sun is 8 minutes old. The moon is just over a second old. Okay, Jupiter is several hours old. You know, and that's how long it takes light to get here from there. It's pretty amazing. Okay, let's go back here. I would like to do the Pac-Man nebula right now. What do you think?
Sure.
Yeah. We also had the Little Rosette. Little Rosette, I think, is right near this. Yeah, we'll do that first. The Little Rosette is cool. You'll watch the telescope move up just a little bit.
C. Ramos also says, are there cases of past stars whose light is passing through the same place but in parallel? I'm not sure how to respond to that.
Let me see.
Hmm?
Oh, I see what he's saying. Yeah, of course. I mean, photons can pass through other photons, is what you're asking. You know, they're not physical particles. All right, it's radiation, electromagnetic radiation, and that can pass through. They can pass through each other. All right, let's see now. Let's go here.
I heard it put in an interesting way recently. Photons have momentum, but they don't have mass.
Yes.
They are energy, and since energy is, E equals mc squared, well, they can't have momentum, even though they have no mass.
It's relativistic momentum. Yes, it's okay. You have there's different definitions of momentum, and so photons don't have mass, so they can't have mass times velocity, which is the typical momentum equation. Okay, however, they do have the Planck constant times frequency, h nu or hv. It looks like a v. That's the relativistic momentum of a photon. And E equals mc squared is actually a more complicated equation, and it drops down to E equals mc squared if you have something not traveling as fast as light. Something that moves at less than light speed has mass. So E equals mc squared does not apply to light. It applies to everything other than light. So in fact, the actual equation is E equals the Planck constant h times the frequency nu, and that's a Greek letter nu, okay, plus mc squared, effectively. And so that's the equation. That's the whole Einstein mass equivalency equation. And so there's the special case where something's not moving as fast as light, brings it down to the famous E equals mc squared that everybody knows. And that's the only reason it's E equals mc squared. It's usually h nu plus mc squared. So that's the whole equation in the real world. So light has relativistic momentum. It doesn't have actual mass-related momentum. So you're right
Yeah.
about that.
This is why solar sails work.
Exactly. Well, solar sails also are responding to high-speed protons from the solar wind. And those are physical particles that are moving less than light speed.
Yeah. Which brings up a question old school DIY said. Can the protons pass through the star, though? Uh, when fusion creates energy, that's not right. When fusion occurs in the center of a star, yeah, photons are released. Uh, the photon that emits from the surface of the star is not necessarily the same photon that got released in the center of the star. I mean, they're colliding constantly inside, and they're absorbing and emitting new photons constantly.
That's right.
It may take those photons to work their way out thousands of years to get from the center of the star to the surface and
Hmm.
pop out so we can see it hit us. But the photons themselves are, by nature, traveling at the speed of light.
Yeah, and here's the little wrinkle there. Let's suppose you could become a photon. The entire span of your existence will happen in an instant. Okay, we got to go down a little, I believe. Oh, yes, it's a little rosette. That's right. And the reason I say that is for the following reason. When we look at the speed of photons traveling, we see a photon, we could see it go by at the speed of light. Zoom. We could measure that movement. Okay, send a laser beam at the moon, and we get it back in just over a second, right? So we look at that speed it travels to the moon and back, and we say, aha, that these photons and this laser beam we're sending to the moon are reflecting off the lunar laser the retroreflector array up there, which was made in my university, by the way, and it comes back to the Earth. We measure that time, and that's how fast it took those photons to go from here to the moon and back, right? So now we can measure how fast light travels by that process. However, if you were the photon and you press the laser to the photon, this is relativity, and you got to just accept some things in relativity. To the photon, from the time it was emitted to the time it was detected, is one and the same time. It's instant to the photon. There's no delay. Because from the photon's point of view, it's moving at the speed of light, and therefore time has no meaning. And so everything is happening at the same time if you're a photon. It's a kind of a strange way to think about things. And now that I confused four out of 5 people out there, it's just the way that relativity works and the way that light works. But the nice thing is there's no conscious photons. So we've never had a report back from a photon saying, hey, I just did that instantly, But we do know how things that travel at light react. You go to time slows down, right? So time slows down as you approach the speed of light. Not for you. If you're in a ship traveling 99.999% the speed of light, you throw a ball at the wall, it comes back just like it does here. But there's someone watching you go by. Say you throw the ball, and as you come by, the ball is in the air. For as long as they can watch you, that ball will stay in the air, maybe traveling a little bit more toward the wall. Because from people watching you outside your ship is in what's called a reference frame. Outside that reference frame of your ship, watching the ship go by, you're sitting still, and you'll always be still for the rest of their lives, with a ball moving very slowly toward the wall, maybe detectable over a period of years if you keep looking at the ball in the ship. And that's relativity for you. Welcome to the conundrum. Welcome to the madness that is relativity.
And if you're falling into a black hole,
Yeah, okay, here we go. That's a good one.
people watching will never see you go into the black hole.
Right.
you'll slow down sort of infinitely before you ever get to the black hole from an outsider's point of view.
Yes, you can imagine, as Daryl's alluding, that as you fall into that black hole, the light is still coming out as long as it doesn't pass the event horizon, where light is now bent so much that it has to follow the fabric of space, which takes it in a curve that keeps it inside the black hole's confines. However, just before that, the light can still come back, but what will happen is there'll be a reflection of what was there on the very surface of that event horizon for a period of time before it also fades away. And that will be the photons that are not really sure which way they're supposed to be going. Okay? And that's the easiest way I can think of saying it. And so those photons will make a ghost image on the surface of the black hole. And it won't be there forever and ever, but it will be there for a period of time. And I should prepare a way to talk about that period of time and how we calculate it, because that might be pretty cool. But it is kind of cool, and it's a neat way to think about the universe when you think about black holes.
I don't pretend to understand it, but some people are saying now that dark energy comes from black holes. As far as competing theories of dark matter, well, I mean, black holes seem almost too mundane, but that is one theory of what dark matter is black holes.
Yeah.
There might have to be a whole lot more black holes in the universe than we know of.
Yeah.
Basically a whole lot more mass tied up in black holes than we know of.
Could be. Yeah.
As far as them emitting dark energy, though, your guess is as good as mine. I have no idea.
Yeah, that's the thing, just because it's a black hole doesn't mean that dark stuff comes out of it. We do know that there's energy emitted, and that energy emitted by a black hole is actually what's in part going to lead to its evaporation. All black holes evaporate. All black holes. They all evaporate. They'll eventually be gone. But the time frame over which that happens is huge. Huge. So there's no doubt that a black hole that's a supermassive black hole, an SMBH, in the middle of a galaxy, for the life of the universe will not evaporate, even if it stops having stuff thrown into it, because it takes a long time for evaporation to occur. Now there's micro black holes, extremely tiny black holes. They live a few nanoseconds, and then they're gone. But their bigger brothers and sisters will last for quite a long time. So I think that's cool. Karen's asking you a question, I think.
Yeah, I just answered her.
Okay, so here's the little rosette, and you can see that there's a small cavity in the center that's been excavated by the stars that were in here. They've started to disperse, so you can see that now that they're no longer really in the center, that this cavity making process is probably no more. So this is more of a mature nebula. That's cool. All right, so we'll save this like it is. And we'll move on. We're going to go to the Pac-Man next. Because I mentioned we would go to the Pac-Man before, so we'll do it now.
You sound like you're losing your voice.
Oh, my voice was gone. So this is the second day where my voice is reasonably functional. And that's only because of the fact that I talk too much. Something you won't argue with, I'm sure.
Ricola.
Yeah, I have those. They're not Ricolas, though. I couldn't handle Ricolas. They're too powerful. I got these honey ones that have like honey inside of them. And as soon as you get to a certain point, they break open, and all of a sudden you get all this honey. And it's like, I didn't know what it was at first. I was like, oh, what's in here? I couldn't really taste it at first, and then I realized, wait, this is the honey. Okay. All right.
They make Ricolas and honey lemon mint or something like that too.
Really? Oh, that's nice. I'd like that. All right, let's go in here. We're going to go to the Pac-Man Nebula now. It's also nearby. It's actually higher up in the sky. And this will look like Waka 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 Waka. It'll look like the Pac-Man. So you see our telescope stars moving. You'll see our SkyTour crosshair show up in here. Okay. So this is the Pac-Man right here. You can kind of see it. I'm going to move us south a little bit up first. I'm going to make sure that our settings are good. Yep, we are. So move south. Okay. And I'll move east a little bit. So all the stars will shift to the right. Okay. And let's see if our system knows Pac-Man. It should. It does. Okay. There we go. All right. It knows it. And we're there. So, let's do this one. And this is the Pac-Man Nebula. And I'll call it that here. Alright, Pac-Man Nebula. Nebula means cloud, and it's either gas or it's dust. A dark nebula is dust. A emission nebula is hydrogen, glowing hydrogen emitting red light. Okay, so we're going to do this. Will be 25 seconds. Okay.
Elisha is here.
Hey, Alicia, how are you?
Elisha.
It's just lonely old me today. Oh, sorry to hear that. I guess Darlene's probably in bed already. Okay. Let me clear this. There's the Pac-Man. It'll be back. All right. All right, we have 6 seconds. 3, 2, 1, 0, and we should see the Pac-Man right there again. And there it is. So you can see it looks like a Pac-Man, okay? If this is the eye, okay, this is the open mouth, waka, 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 waka. And that's why it's called the Pac-Man. Let's color correct this emission region with dark dust. You can see this dark nebula silhouetted by the brighter gas behind it.
I wonder what they called it before the video game came out.
Oh, that's, I bet you that is just the name that is, NGC 281 is what it is, or Sharpless 2-184, or Lynn's Bright Nebula 616,
Or Lafitte's Grand Isle.
Lafitte's Grand Isle is probably what it was. No, it's always been called the Pac-Man, and that's what made the game. No, it didn't. Karen Belmont says that lower jaw sure is scary. Yeah, don't bite me with that. That's right. Dean Bustador says, this is nice. Exploring the winter sky as our first snow begins tonight. Oh, sorry to hear that, man. Oh, yeah. James Hyde, how you doing? I noticed you were here, and I didn't say hi until now. Very cool. Okay, remember, we're doing a contest, but tonight we're going to have two winners. 2 sets of binoculars. Pick a number 0 to 1,000. If you haven't done it yet, put your one entry in the chat. Now, if you have subsequent entries, only the first one you enter is the one that we're going to take. So you can't just put in all kinds of numbers and hit enter, because only the first one is the one we're going to take. All right. So you're going to win a pair of Celestron binoculars, and there's going to be 2 winners tonight. And this is a kind of a sort of a memorial giveaway for Cindy Murphy, one of our longtime viewers who passed away. Her daughter Heather contacted me and let me know. Very sad. And Cindy really enjoyed our SkyTour live streams. And it was really unbelievable of Heather to connect with us and let us know. That was very, very kind of her. So, in any case, it's a memorial giveaway. We're giving away 2 binoculars. Make sure you enter a number between 0 and 1,000. Put it in the chat. You have 1 entry. The first one you make is the one we're taking. Okay. Pac-Man is in a very starry area, so you see a ton of stars in here. Looks like I need to focus. Well, I only did 8 shots, but I'm going to stop because I need to refocus the telescope here. So we're going to go to our low light mode again and do a quick focus run and restart all this, because we're not quite focused. All right. Technically, as I've told you guys before, I should focus every time I go to another object, but I don't. Sometimes I don't need to. Alright, so let's do this now. This is the full width half maximum filter. What it does is it takes the image of the star that it sees. It sees 19 right now. See the yellow squares? It's surrounding the stars it's seeing. We're zoomed in, so if you want to see the rest of them, we zoom out. And there you see the full field of stars it's looking at. And what it's doing is it's optimizing the size of that star image and building a curve. When the star is smallest, it'll be at the bottom of the curve, and that will be the perfect focus. It's an algorithm written by Robin Glover, and he's quite dedicated to this, being the author of SharpCap and the person that is really, really good at this stuff. I'm just writing a message to Heather Murphy right now, who just messaged me. Okay. Okay, there's our focus, the bottom of the curve as promised. And what happens is the telescope is moved to the best focus position. And now when we get out of here, all right, if we zoom in, we'll find that the stars are tiny dots and not bloated objects. You see that? Tiny, nice dots, just like we expect. Tiny dots. Okay. Now we're going to do this again. I'll make it here.
For the folks talking about snow, we had almost Albuquerque low. It was an Albuquerque low. Here last week, I guess, got 22 inches or so of snow here total. Some places up in the mountains west of here and south of here got over 3 feet of snow. And out on the eastern plains, some places really got it too. If you look at satellite maps of the U.S., you'll still see big, huge snowfields out in the plains in eastern Colorado that are still sticking around. They'll get drifts out there many feet deep during blizzards.
I never realized, how much blowing snow was a problem there until I saw the snow fences.
Oh, yeah.
Marianne says, Richard, because she was talking to Richard McFarland, Richard, I will definitely send you clear skies if you would please send me some rain. No way. No. Richard, don't listen to her. Do not send her rain, because if it's going to rain for Marianne, it's going to rain for us at the observatory. So everybody just pick your poison. Do you want rain or no rain? There. I'm probably going to win that one. Alicia says, I can remember standing on a snowdrift in Burlington, I'm assuming Burlington, Vermont, and falling through it. Or is it Burlington, Texas? I don't know. Burlington, Vermont, I would guess.
There's Burlington, Colorado, too.
Oh, that's true.
Out on the plains.
Yeah. And falling through it as a kid. Yeah, I was standing on a drift like that and fell in. It was like, wow. And I started making a snow fort. Back then, we didn't think anything would collapse on us and hurt us. So it was really cool. Burlington, Colorado, she says.
There you go.
Yep.
I believe it out there.
Yeah, it's incredible. Notice the stars are a lot more focused here now, so it's looking better. Let's see if we can get a little extra data out of this. Okay, that softens up the noise a little bit. Let's color correct, which won't do much right now. Let's hit the others. I want to do this for a minute. Okay, and then this. Very nice. Okay. And pull this in.
We had our first night in the teens last night.
Oof.
And 40s today, 50s tomorrow, and then back up in the 60s, I think, for Friday and Saturday.
Oh, by the way, I have to make an announcement before we go further. Just so you know, I don't know if anybody put it in the chat. You do not have to be present to win. If you put a number in and you just have to go to bed or you have to leave, don't worry. I'm going to put the winners on the website. So you can go to skytourlive.org and scroll down and see the winners of the contest, okay? If you have to go to bed. If you're going to stick around to the end, to be fair, you've only got another, I'd say, 20 minutes before we're going to stop. I have to give my voice a rest. I have to be in good shape because on the 25th I got to do my. That's 5 days. I got to do my pre-interview with A&E because I've got the History Channel, the second batch of the History Channel stories to do for Proof is Out There. That's an A&E company. So I'll have to get my voice back by then, fully, because I'll have to be talking all day long. They come here to film. You know, actually the computer I'm on is the one we actually use for filming, which is kind of fun. Yeah, make sure you put your numbers in, guys. Make Tiffany do some work. And she's actually doing double duty because we're going to have 2 winners tonight. Alicia says, I'll have to tell Darlene it was funny to see her recognize you on TV. Well, you sent me a photo, Alicia, of Darlene pointing to the TV where I was doing some dumb thing, which I thought was great. Mm-hmm. And Sabazerker, how you doing?
Saber, I think.
Yeah, Saber Circer. It looks like I was reading. That's funny. Thanks, Daryl. It's like funny how you read things. Saber Circer. I'm from Europe. Is that disqualified? No, it's not. As Tiffany just said, you can win. Of course you can win. The only thing disqualified is Antarctica, I think. Well, maybe not, because there's flights out of New Zealand to the McMurdo station. But I don't think we have anybody from Antarctica watching. It's my goal to have one person from every country watching us at some point. That'd be kind of cool. Look at the detail in here, guys. This is dark nebula, again, sitting in front of the bright nebula back here behind it. Okay? That's what this is right here. It's a dark nebula sitting over the top of this bright nebula. So, as we zoom in a little bit here, you can see the details of this feathery-looking material. This feathery-looking material is material that's made of carbon and silicon, all right, the byproducts of supernovae from stars, the byproducts of red giants that are sloughing off their outer layers and making carbon molecules in their outer atmospheres and leaving them in space. And then those things get moved to different locations through stellar winds from countless trillions of stars. You know, and if you look right here, you'll see a very interesting feature. Look at this guy right here. We'll zoom in. It's going to be a little bit. We only have 15 images here, but you can see this object right here is really neat. It looks sort of squarish, and you got another little extension to it here. There's more out here. These are little radial pillars that are sticking into this region because there's a cluster here. And guess what it's doing? It's eroding the material on the outside. It's carving a cavity around this cluster. And it's making little pillars. Here's a pillar aiming right at the cluster. Here's another one aiming right at the cluster. That's how this works. Here's one right here aiming at the cluster. And so where there's dense material, it stops the erosion and the stuff behind it is preserved. Here's one right here.
Can we try that supernova after Pac-Man?
Yeah, it was a magnitude 16, but we'll try it. We could see magnitude 17. So we'll try it.
Camelopardalis is high in the northeast now. Probably a good time for it.
Yeah, well, I couldn't do it before because we had to wait for it anyway. So I think we could do that as a last object. It may be a disappointment, though, if we can't really see it. But we'll try. Saber Circer, if you want to win a pair of binoculars, did you enter a number yet? There's going to be 2 winners tonight, so you have double the chances to win. Whatever number you enter first, that's the number that will be taken. And of course, we have Steven Smet here. That's Mr. Django. He has a cool site, Mr. Django's Backyard. About astronomy. Yeah. I was in Arizona, Mr. Django. I was showing people the observatory here, our new location. So that's why we didn't quite get to doing our streams, because out there, although we have good internet, it's also a lot of work, a lot of stuff going on. I didn't have time to actually put together a stream. But tonight we did. And we'll continue. Now that the moon's on the backside of its... and that coupled with the moon rising and being in the way, we didn't want to be there when the moon was waxing gibbous, getting larger, going to full moon, and then waning gibbous is pretty good. Right now it's approaching last quarter. So I think it's okay. To Rivers, we're giving away 2 pairs of Celestron binoculars tonight. So if you enter a number between 0 and 1,000 in the chat, if you're the closest to that number, you will win. We usually only give away 1 set of binoculars, but thanks to Tiffany Echo and her generosity, she is, because of course tonight is a memorial stream for Cindy Murphy, who had passed away. She's one of our most wonderful viewers. What we're doing is she's doing a memorial giveaway, and she's doing double the giveaway, so we're doing 2. And Stan says 576. Okay. Tiffany will grab that number, and we will have the winners before the end of the stream. And you don't have to be here to win.
Moon rises in 33 minutes.
Right. So I'm trying to get to that supernova here. Hey, Steve Tuttle. Thanks for putting in your number of 837. Steven Smet. Mark your voice. Yeah. Yeah, I got a cold, and I actually lost my voice entirely. Today's the second day it came back, and wouldn't you know it, I have to start mouthing off and do a stream. But look at this. Look at this thing. That's beautiful. This is the Pac-Man nebula. It's really incredible. Just beautiful. We'll save this here, actually, too. Yeah, I heard that. You sound like me.
Sorry.
That's fine. JSEO 77, how you doing, man? Yes, these, you got to keep in mind, this is all in 3 dimensions, so we don't know what's closer to us or further from us except for these dark nebulae. We know those are in front of the nebula. Thanks, JCO. It's good to see you too. If somebody asked for Thor, oh yeah, Stan did. Yeah, Thor's helmet is Monoceros, and that's actually further east of Orion, so we have a ways to go.
Canis Major.
Canis Major, right? Okay, yeah. I thought it was Monoceros. Huh? Close. They're right next to each other. Wow. Okay, let's drop this down a little bit to get rid of some of this noise.
It'll be here before you know it, Stan.
I know, and then it'll be gone. You'll say, where'd it go?
Winter is coming.
Karen Belmont says, does Arizona have a, I think you meant crappy, not carpy, month of clouds, like Minnesota, November, December, January? July, actually. End of June and July is the monsoon, what they call the monsoon, where they get about a 2500th of an inch of rain. No, I'm just kidding. But that is the monsoon season, where you get a lot more clouds than normal. And it's during the summer. Wow, look at that.
Same here, maybe a little later.
Mm-hmm.
Summer monsoon shows up. Clear every morning. Starts clouding up promptly at noon.
Mm-hmm.
May or may not rain, then it clears overnight again. Rinse and repeat.
Mm-hmm. Yeah, this is really something. Let's push this to see what else is hiding in here. So here we go. Yeah, you can see there's a little bit more hiding in here. I've actually never seen this before, Daryl. This is neat.
We've seen it before.
Yeah, but we haven't seen the exterior details out here like this. Everyone's saying, sounds like Texas, sounds like Minnesota, sounds like Kansas, sounds like Connecticut. Okay, we're going to go to 20. Oh, no, this is 34. We're going to go to 35. And then we'll save it here. All right, there we go. You'll notice that none of our frames have been rejected. What that tells us is it's a very calm night out there. We haven't had any wind. Okay. Well, this was technically our last object, Daryl, but if we have that supernova to look at, let's go do that.
Okay.
So, where are we going? Camilo Pardalis. And
Camilo Pardalis. The galaxy is NGC 2146.
okay, let's do that. NGC 2146.
Supernova probably has, well, it is labeled now, but probably not in your database.
All right, this is the Dusty Hand Galaxy. Kind of looks like an interesting galaxy to me. It's a barred spiral.
Yeah.
Okay, well, let's go there and see if we can make heads or tails of this. I think we can try it. Why not? All right, let's go. Well, it's high enough to see. This view lags behind the telescope motion. You see the telescope move. And now... Okay. Here's the galaxy, I believe. It might be.
I have to tell my Camilo Pardalis story.
Oh, please do. That's a
Many
giraffe.
years ago. Thanks.
Oh, what?
What?
That was the story? I didn't
Oh,
I'm sorry.
That was the punchline.
Oh.
Yeah.
Tell it anyway. No one's listening to me. I'm sorry.
Many years ago, my family was all together, and we were playing Trivial Pursuit. That tells you how long ago that was. And it was me versus everybody in the house, everybody else in the house. And not to brag, but I have some very smart people in my family. Well, I pulled a card and it said, "What is a camelopard?" And I knew I had heard it before. It didn't come to me offhand. And I'm sitting there scratching my head thinking, what is a camelopard? And I remembered that it is a constellation. It's up in the high northeastern sky this time of year, sort of following Cassiopeia and Cepheus, if I remember correctly. And I remembered it as a constellation, and I remembered it was an animal. So I'm still thinking, sitting there thinking and thinking, trying to figure it out and remember. And my brother-in-law's wanting to buzz me out, time me out. He's a high-priced lawyer, and it hit me. And what I did was, well, I thought to myself, what do you get if you cross a camel with a leopard? Imagine a camel with leopard spots. What animal would that be? And it came to me, and I said, it's a giraffe. And I won. And he was really ticked off. Anyway, a camelopard is a giraffe. And that's what the constellation represents.
And you didn't hear it from me.
I figured it out myself.
Yeah. All right, there's our galaxy. So I'm going to stack it now. And we'll get rid of the Pac-Man nebula. You can see how small the galaxy is here compared to the Pac-Man nebula. Of course, the galaxy is many, many light years further away. And exactly how many light years further away? Let's go see. This galaxy's distance is 127 million light years away. So this object, which you'll see in a moment, let me drop this out. Okay, this galaxy is 127 million light years away. And they said that I think Mort told us it was a magnitude 16 supernova now.
I think so.
Okay, I need to know where in the galaxy it's located.
Yes, I'm going to go look for it right now.
Okay. I'll do a color correction here. And let's do a little of this. There's another one over here. So here is what we're looking at. Here's our galaxies right now. This is 2146. Beautiful dark lane in this galaxy. I'll save this with annotations if someone wants to capture that. Alicia, thank you for coming. Nice to see you. Have a giraffe dream. And did you put in a number, by the way, Alicia? Make sure you did. Daisy and Zoe are here too. Hey, guys. Remember, we are doing two winner contests for Celestron binoculars tonight. So Daisy and Zoe, enter a number between 0 and 1,000. And we shall be able to see if you get closest to our number. And if you do, you can be one of two winners for Celestron binoculars tonight. Okay, let's see. Alicia did. Okay, thank you, Alicia, for putting in. Thank you, Michael, for telling me as well. Alright, it says magnitude 16.5 from Mort.
Well, darn it. I found one image, but they don't say which one it is.
Mm. It's probably going to be in the galactic disk here.
Oh,
The spot is on the right side.
Yeah.
You see two stars in line, then under that one. Right side, two stars in line. I don't know what two stars we're talking about. This star and that star? This star and that star? Let's go in here. Wow, look at that dark light in there. That's pretty. Let's drop this down, get rid of some of our noise.
Okay, it's I do believe it's can you get your pointer up on the screen? Okay, to the right, directly to the right. Right there.
That's it?
That's it.
Oh, how cool. Alright, so we found ourselves a supernova, guys. Thank you, Mort Ort, for passing that on to us. So the galaxy is over 127 million light years away. And we can see the light of one star that's exploded 127 million light years away. That's cool. That is cool. Alright. That's neat. I think that's pretty cool. Okay, we're going to set that as our target name.
I can drop the image I found into your Skype if you wanted to compare it.
Can you do it? I won't do it tonight, but I will check it out tomorrow.
All right.
Oh, very nice. Okay. So this is the supernova, guys, right here.
And if it, when did it happen again? When was it first seen?
I don't know.
Detected November 15th at 2 p.m. Universal Time.
Okay.
So it's the 20th now, so it's still young. It may well get brighter.
Mm-hmm.
5 days old. Gosh, how many supernovas have we seen? I know there's been several.
Yeah, we've had several here. There it is, right inside that square. That's it. Actually, let me make it a little smaller. So inside this square, that's our supernova.
You're seeing a huge, huge, huge explosion from 120 some odd million light years away.
That's right. That's a big one. All right, let's do our...
And if it's just days old, it may well brighten a lot. Still
Yeah,
fighting, still brightening.
very cool. So there it is, and that's pretty cool right there. We're going to actually have to come back to this and see it. Now, we've got 18 exposures right now, and the galaxy's getting a little bit clearer, a little bit better. Turn on our unsharp mask, which is a sharpener. And you can see the galaxy supernova a little better now. Actually, that's a very interesting point.
Type 2 supernova too.
Yeah.
Perhaps you can remind us what a type 2 is.
Yeah, well, you've
Core,
got, yeah.
core collapse?
Yeah, the core collapse supernovas are very interesting because when you have a star that runs out of its nuclear fuel entirely. Now, when a star starts burning, it'll start burning and fusing in several shells around the core. You'll have shells that are making hydrogen into helium, helium into carbon, carbon into oxygen, and so forth. And you'll end up having silicon being made as well. And silicon, it's interesting, all the silicon in the universe comes from one day of fusion in the star's nucleus. Because what that means is every star that's ever gone supernova will be making silicon for one day, the last day of its existence. And that silicon gets spread to the cosmos when the star goes supernova. That's where silicon comes from. So we have so much of it on our planet, yet it comes from the most unbelievable place. It comes from a supernova. And only one day of silicon burning is done in a star before it goes supernova. All right? So the core collapse, when everything stops, the star is pushing out with a lot of radiative energy to overcome the massive gravity trying to collapse it. And so that pushing out of energy balances the downward pull of gravity, and that's called hydrostatic equilibrium. All right? So once a star's in this equilibrium, it can go like that for millions of years if it's a massive star. A star like the Sun, the forces aren't as dire, and it can last billions of years. But these big stars, they get about 3 to 10 million years, and then they go supernova. So the brightest candle snuffs out early. And so when all those materials are done fusing, now gravity wins. And from all sides, the core collapses. But in the very center of the core is iron. Iron is the last element that can possibly be fused in the star's core. Iron can't be made into anything else, right? Not under normal conditions. So it's a solid thing stuck inside the center of the star, and it can't go anywhere. So when everything collapses onto it, there's a rebound effect where it bounces back out. It's falling in at a fraction of the speed of light. And that core can collapse in as little as a quarter of a second. And the core is 20% the size of the star. To give you an idea. Now our sun's about 860,000 miles across. And the core is about 20%, 15 to 20% of the sun. So that's still a planetary plus sized core. All right. It's actually quite a lot larger as at 20%. It's many Jupiters in size or so. And so when you think about it, okay, when you have a core that's going to collapse and it collapses fast, that rebound effect is very strong depending on the mass of the star. And when that stuff comes shooting back out at high speed, it's impacting the stuff still falling in from further out in the star. And so this is what contributes to disrupting the star. Now, at the same time, a little known fact is that the stars, just before they go supernova, create another set of particles by the trillions and trillions and trillions, and these are called neutrinos. The neutrinos are sent out, and they don't get stopped by much, but they have trouble getting out of a supernova underway. And when they come out at the speed of light, all right, unlike the actual mass, the material, which moves out much slower. When the core is collapsing, it's physical material that's collapsing, nuclei of atoms. That's physical matter, all right? That stuff is collapsing into the core, all right? And neutrinos are light energy, so they come shooting out. And about 1 in 1 billion neutrinos actually gets out of the star. But that's more than enough for trillions of them to get out. That's how many are being made. Okay, so what we'll see before a supernova explosion is a neutrino burst. And so if we saw neutrinos coming from this part of the sky, We could have said, hey, there's an active supernova going on. We better turn our telescopes to this galaxy and check it out. And yet we wouldn't know. We wouldn't see anything because it's the energy particle, the neutrino, that gets out first. Now, the material, the physical material, is still rumbling and roaring out of that center on its way to the outer edges of these massive stars. And it could be hours and hours and hours before it actually gets out. And it's boiling its way to the top. Because these stars are going to be big supergiant stars. And so they could be the size of Jupiter's orbit in diameter. That's huge. All right. So it might take hours and hours for the actual supernova shockwave to get out. It could take a day for the supernova shockwave to percolate from the inside outward, ripping everything in pieces. And when it finally reaches the outer environment, it blows out the star. And that's when we see that a physical supernova occurred. But we would have had hours and hours of notice because we would have seen the neutrino stream first, if we were looking. And that's what happened here. I don't know whether we saw the neutrino stream or just discovered the supernova. We could do supernova searches. We could go from galaxy to galaxy to galaxy to galaxy and just take picture after picture after picture, just like 10 shots of one galaxy, 10 shots of another, and do that all night long. And we could do supernova searches. And maybe we'll find some. Marianne says, wow, this is so amazing to have a wonderful STLS family from all over the world. So honored to be hanging out with you guys tonight. Hey, well, thank you, Marianne. It's my honor to hang out with you too tonight. Yep, very cool. There we go. You see this dark lane here, Daryl?
I'm sorry, say again?
See that dark lane here?
Yes.
That's really pretty. Let's zoom in.
It's a barred spiral. Well, I guess I see a spiral now. It looks badly distorted, though.
It does, because this lane is going sort of the wrong way.
Yeah. The one leg of the spiral, if that's the central bar there
This is off.
on the right side, it's falling off very faint to the lower right.
Yeah. Over here.
Yes, down from there.
Okay.
And then the other, that right there. The other spiral arm is over on the left, and it's going up slightly.
Well, I see this. You see that? Looks like that's where it goes.
I see that, but I think there's a little faint component
Oh, yeah.
falling off below the supernova down toward the bottom.
Well, I'm going to pump it up artificially here. Let me back out. I see some here. And there. And
Oh,
here.
there's more. There's more. If you go right to the supernova, there's a faint brightening dropping off to the bottom and to the lower left from it.
This here.
No, farther down.
Oh.
Right there.
This?
That and going up.
Okay. To here? Or to here?
To just above the supernova.
Okay, so to here.
Yes.
All right. I'd have
It
to look
looks
at
like
the...
one spiral arm, and the other spiral arm is over on the left, pointing to the upper right.
So maybe it's this is the outer extent.
That's what I assume, yes.
Yeah, okay. Yeah, that's what I'm trying to find out. Okay. And let's see if we can accent that by bringing this mid-level in. And maybe by darkening it up. Darken up the space around it. Wow. All right, well, I think that's pretty cool. So we'll save it. We did capture the supernova. So as you can see, we can see magnitude 16 objects quite easily. Very cool.
2146 is the barred spiral galaxy type SB ABPEC.
Peculiar.
I think that's the word I was looking for. Peculiar.
Okay. All right. Remember the contest tonight, guys. If you haven't entered your numbers, do it now. Between 0 and 1,000. Enter one number, and if it's closest to the magic number we've selected, then please indeed know that you may win a pair of binoculars. Okay, I want to say hello to Roxy in New York City, who's watching us on the big screen right now. Thank you, Roxy, for sending me a message. And hopefully we've got other people watching as well. It turns out we always have a lot of people watching who we never even know they're watching. Hey, thanks for putting up that link.
Sure.
Okay, I'm gonna pull this back here. 45 shots, that's good. Alright. And now it's time to give my voice a rest. One more time, guys. This was a memorial stream for Cindy Murphy, one of our faithful SkyTour family members here. Most of you probably knew her. And thank you to her daughter, Heather Murphy, for letting us know. And our condolences to the entire family and those who love Cindy. For sure. Okay, Tiffany, we are actually... Oh, Chris Mindfork, how are you? Alright, make sure you all get your numbers in between 0 and 1,000 to win the binoculars. Closest number wins. We have a magic number we've selected. If you're close, you win. We're doing 2 winners tonight as a special memorial to Cindy Murphy. We're doing an extra pair of binoculars. So let's try and let's do something she would like. Let's win those binoculars. All right.
Whoops.
All right, let's see here. No, Cindy will never be forgotten. She was crazy good. She's crazy cool. She was really interesting. Tiffany, if you're ready, let us know. All right, we're gonna go for it. We're gonna pick the winner. And I'm just gonna wait for Tiffany to announce the winner. She's tallying all the numbers. Daisy and Zoe say 757. Okay, your number has been entered. This is for 2 pairs of binoculars tonight. Tiffany's ready. Okay, Tiffany will now announce the winners of the binoculars. Yeah, James, Chris is mind-forked. I've seen her a few times at different conferences. Really cool lady with lots and lots of energy. All right, the two winners are Karen Belmont with the number 7 and Richard McFarland with the number 5. Congratulations, guys. That is fantastic. I miss you too, Chris. It's so good to see you out here. Alrighty. The actual number, the winning number, was the number 8. The number 8. Doesn't always have to be 1,000 or in the hundreds. And so tonight, I think that's really cool. So Karen and Richard, you both won a pair of binoculars from Celestron. And what you need to do is go here. Go to skytourlive.org. Okay, and go to the upper right corner on that site, and it'll have an email or a contact us, and send me a message with your address, where you're located, and I'll make sure those binoculars get out to you right away. So that'll be a happy Thanksgiving to you guys. Hello there, Lady Astrid. I didn't see you before, and Judy M is here too. That's nice. Jessica, you're full of pictures.
SkyTourLive.org, don't forget.
Yeah, go here.
Upper right corner.
Yeah.
Are you showing it?
Yeah, I am. I was just saying so.
Oh.
That's okay.
Sorry.
No, that's good. I wanted you to. That's fantastic.
I don't see it on Skype.
No, you won't see it on Skype. But you're right. And so go here. Go to skytourlive.org. And in the upper right corner, you'll see a link to contact us. Please do. And send us all of your information we need in order to get you these binoculars. All right. So happy early Thanksgiving to you. Happy really early and merry really early Christmas to you. And so make sure you send me that stuff. I hope you had a good time tonight. This has been a memorial stream for Cindy Murphy, one of our SkyTour family who unfortunately we've lost. And we will miss her greatly, and she'll never be forgotten. And her family has our condolences. And everything we did tonight, we did for Cindy. So I hope you all have a really good night. We're going to call it quits for tonight. My voice is already quitting, as you can tell. But I will do my best. So we'll see you guys later. And remember, guys, winners, Karen Belmont and Richard, go to skytourlive.org and send us that email in the contact form so we know where to send these binoculars. All right? And you don't have to be here to win. If you just check the website tomorrow, you'll see the names. I'll mention that in the subsequent stream and in the community conversations in our chat. So good night, everyone. I hope you had a good time. We had a great time with you looking at all different objects, things we haven't seen really before. So we'll talk to you in the next stream. All right? So we'll see you all later. Bye-bye.
Good night, all.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the sky. a distant dream. Live it real, like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky Tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky Tours bringing the views, every night feels brand